Hi guys, in the previous lecture we have covered the two-port network, and in this lecture we will be studying AC circuit. So before solving AC circuit, I would like to highlight some basic information about AC. What do you mean by AC? AC is a signal whose magnitude and direction changes with respect to time. It is a signal whose magnitude and direction both changes with respect to time. Let us consider one voltage Vt is equal to Vm sin omega t. If I will plot the waveform of Vm sin omega t, then I will get like this, okay, whose maximum value is Vm and whose magnitude is changing with respect to time, as well as direction is also changing after certain interval. So here three things you are getting in Vm sin omega t. First one is the Vm. Vm is the maximum voltage, right? Then you are getting omega. This omega is the frequency in radian per second, okay, whose value is given by 2 pi upon t. T is the time period, or you can say that 2 pi f. What do you mean by t? T is the time period and f is the frequency, and we know that t is equal to 1 upon f. Now what do you mean by frequency? In India the frequency is 50 hertz. So what do you mean by this? This means this waveform completes 50 cycles in 1 second. Got it? Now what do you mean by cycle? Cycle means this positive half plus this negative half. This whole get one cycle. So this is the one cycle. So if any waveform has a frequency 50 hertz, that means in 1 second that waveform is completing 50 cycle, right? So how much time it will take to complete one cycle? One cycle is completed in 1 by 50 second, right? That is equal to 20 millisecond. So if I will ask you what is the time period of this waveform, then you can say that this is 20 millisecond, right? And this is also known as time period. So we can say that to cover this waveform from 0 to pi, it will take 10 millisecond. So to cover this waveform from 0 to 90, it will take 5 millisecond. To cover this waveform from 0 to 30, it will take 5 by 3 millisecond. In this way we can approach. Now before moving to the questions, I would like to say that you should remember this formula. Means sin 90 plus phi is equal to cos phi, sin 90 minus phi is equal to cos phi, cos 90 plus phi is equal to minus sin phi, and cos 90 minus phi is equal to sin phi. We can represent this equation cos 90 minus phi as cos phi minus 90 is equal to sin phi also. Why? Because cos of minus phi is equal to cos phi only, so we can represent like this. So in this lecture we will be using these two formula. Means sin 90 plus phi is equal to cos phi, and cos phi minus 90 is equal to sin phi. These two formula I will use while solving any AC circuit. So you should remember these two formula. If you want to go in detail, then you can refer any class 12 trigonometric book. You will find how these are coming. Okay. Now I don't want to make this lecture a theoretical one. That's why I am not going into the detail. What is AC? How many types of AC? These all things you can study by your own, or you can refer any basic electrical engineering book in order to understand the basic of alternating current. Okay. This lecture is totally based on problem solving. Most of the guys are getting problem when to take RMS value, when to take maximum value. So these all things I am going to discuss here. Okay. So let us take first problem. A voltage source of 20 angle 30 is connected with 2 ohm resistance and 2J ohm of reactance, right? And we have to find the RMS value. Now most of the guys get confused that this 20 is taken as an RMS value or maximum value. See, if nothing is given about excitation, I don't know whether the excitation is sinusoidal or cosinusoidal. I don't know about this. So if anything is represented in like phasor form 20 at an angle of some phi, then take that as an RMS value. Okay, do not get confused whether you have to take the maximum value or RMS value. You don't have to take this as a maximum value, you have to take as a RMS value. Why most of the guys are getting confused? Because see here, when you will read the foreign author book like Sadiq or Hayat, then they are taking this 50 angle 0 as a maximum value, which is exactly opposite to the convention used in GATE exam. Because in GATE exam you can see this has been asked in GATE 2003. They have taken 90 angle 0 and 110 angle 0 as an RMS value. So if nothing is given about the excitation, whether it's sinusoidal or cosinusoidal, and some voltage source is represented like 20 at an angle of phi or any magnitude at an angle of phi, then always take that value as an RMS value. So now you know that the voltage source is having a RMS value with some angle 30 degree. So what is the value of current? The current is given by V upon Z. Okay, and what is the value of Z? Z is equal to 2 plus 2J. So write 20 angle 30 upon 2 plus 2J, that will be equal to 20 at an angle of 30 upon 2 root 2 at an angle of 45. Divide this, you will get 10 by root 2 at an angle of minus 15. This denominator angle will go in numerator with minus sign. So 30 minus 45, that is equal to minus 15 degree. And this is the, finally we are getting RMS value. Now suppose you have to find the maximum value. Then we know that in AC, in sinusoidal signal, Imax is equal to root 2 times of IRMS. So Imax will be 10 by root 2 multiplied by root 2 at an angle of minus 15, that is equal to 10 at an angle of minus 15. So conclusion is that if nothing is given about excitation, then you have to take that value as an RMS value. Okay, now see the next problem. In this problem, some circuit is given having one voltage source whose voltage is given like 20 cos 100t plus 30. Now here you know that this is, the excitation is in cos form. Okay, whose omega is equal to 100, this is omega, and this is phi is equal to 30. This is the phase shift. So and this is maximum value. Okay, and you have to find the value of current I1 in 2 ohm resistor. Now I have to make this circuit in phasor form. So first I am converting this equation in phasor form by writing 20 at an angle of this phase shift. Phase shift is 30 degree, and I am knowing that this is maximum value. Okay, now I have to find this value of I1. So I will use nodal, take this node as V and apply nodal here. I will get V minus 20 at an angle of 30 upon 2 plus V by 2 plus V by 2J is equal to 0. So V into 1 minus 0.5J is equal to 10 at an angle of 30. So finally V is equal to 10 at an angle of 30 upon 1 minus 0.5 J. Finally you will get 4 root 5 at an angle of 56.56. Now tell me, this 4 root 5 is maximum or RMS value? Since I have considered the source voltage as a maximum value, so I will get the response also in maximum value. Got it? So the current I1 is equal to V by 2, that is equal to 2 root 5 at an angle of 56.56. This is the maximum value. So finally I have to represent in cosine. How will I represent? 2 root 5 cos of 100t plus 56.56. Okay, now you want that I will not take maximum value, you want to take this as an RMS value, so take it as RMS value, no problem. When you will write this as an RMS, you will get 20 by root 2 at an angle of 30 degree. Okay, now you have taken the source voltage as an RMS value, so I1 you will get that is also in RMS only. Okay, so apply nodal here. V minus 20 by root 2 at an angle of 30 upon 2 plus V by 2 plus V by 2j is equal to 0. So finally after solving this, you will get V is equal to 2 root 10 at an angle of 56.56. Now tell me, this 2 root 10 is maximum value or RMS value? This is RMS value because source you have taken is RMS. That's why the response, that is the V you are getting, that is also in RMS value. Okay, now I is equal to V by 2, V by 2 that is equal to under root 10 at an angle of 56.56. This will be RMS value. Now in order to make the current equation in cosine form, I have to find the maximum value. Since this is RMS value, so maximum value can be calculated by multiplying RMS value to root 2. So if you will multiply this RMS value by root 2, then I will get under root 20 at an angle of 56.56. This under root 20 is nothing but 2 root 5. So finally same answer you will get even after taking source voltage as an RMS value. So don't get confused. Most of the guys get confused, what will happen if I will take RMS value, what will happen if I will take maximum value. It is up to you, you can take anything. So we can find RMS value also, and we can approach by taking RMS value in order to solve the circuit. Okay, so finally what I am getting, I1 is equal to 2 root 5 cos 100t plus 56.56. Since I have taken the cosine as a reference, that's why the answer must be in cos. Now let us take the second questions. In this question, the excitation is given as a sine. In all the book, you will see that they are taking cos as a reference and they are converting sine in terms of cos. However, it is not necessary. If only sinusoidal excitation is given, then you can take sine as a reference also, no problem. If you are taking sine as a reference, then the response, that is the I2, you will get in sine only. So I am taking sine as a reference, then Vi in phasor form will be 20 at an angle of 0 because there is no phase shift. Okay, now I have to find the I2, so I will use nodal analysis here. I will get V by 2 plus V by 2 plus V minus 20 at an angle of 0 upon 2j is equal to 0. So after solving this nodal equation, you will get V is equal to 4 root 5 at an angle of minus 63.43. I am skipping because as I have already discussed about the nodal, how to solve the nodal equation. Okay, so you are getting V is equal to 4 root 5 minus 60.43. Now tell me, this 20 is the maximum value. So response B, what I will get? This I will get as a maximum value. Now I2 will be V upon 2. So finally I2 I am getting 2 root 5 at an angle of minus 63.43. And this is the maximum value because I have taken the source as a maximum value. So finally I can write I2 is equal to 2 root 5. Since I have taken sine as a reference, so answer must be in sine 100t, and it is shifted by minus 63.43. Got it? You can solve this circuit by taking RMS value also in phasor form. But if you will take the RMS value, then you have to first divide by root 2. Then after getting the response, you have to multiply it by root 2. So why to take in RMS value? If excitation is given, then you should take maximum value and approach that circuit in order to find the response. Okay. So finally what I am getting I1 is equal to 2 root 5 cos 100t plus 56.56 and I2 is equal to 2 root 5 sin 100t minus 63.43. Now I am interested in finding I1 plus I2. How will I find I1 plus I2? So since I1 is represented in cosine wave and I2 is represented in sine wave, so we cannot add directly. Either we have to refer sine term into cos or cos term into sine in order to find I1 plus I2. So what I am doing, I am taking sine as a reference, okay, and I am finding I1 plus I2, means I have to convert this cos term into sine term. So I have to write this cos term into sine term. How will I write? I1 can be written as 2 root 5 sine 90 plus theta is equal to cos theta. So we can write sine 100t plus 56.56 plus 90. Sine 90 plus theta is equal to cos theta. So I can write I1 in sine term like this. Okay. Now I2 I have 2 root 5 sine 100t minus 63.43. Now see, I have to add these two equation. Since the frequency of both the sine wave are same, here also the frequency is 100, here also the frequency is 100, so we can represent both in phasor form like this. 2 root 5 at an angle of this 56.56 plus 90, that is equal to 146.56 plus 2 root 5 at an angle of minus 63.43. I can write like this only when the frequency is same. If the frequency is different, then I cannot write like this. Okay. Now I can easily calculate by using calculator. So finally I will get I1 plus I2, that is equal to 2.314 at an angle of minus 138.43. Okay. Means this is the maximum value because I have taken 2 root 5 as a maximum value. So 2.314 sine 100t minus 138.43 is the answer. I1 plus I2 is equal to 2.314 sine 100t minus 138.43. If I am taking sine as a reference, if I will take cos as a reference, then I1 plus I2 will be I1. I will leave I1 as it is because it is already in cos. So 2 root 5 cos 100t plus 56.56. Okay. Now I have to convert this I2 in cosine form. So how will I convert? I know that cos phi minus 90 is equal to sin phi. I know this. Cos phi minus 90 is equal to sin phi. So take phi is equal to 100t minus 63.43. Then you can easily convert sine term into cos term. After converting, I will get 2 root 5 cos phi is 100t minus 63.43 minus 90. So overall you will get 100t minus 153.43. Now I can add in phasor form like this. 2 root 5 at an angle of 56.56, because both are in cos, so I can add directly, no problem. 2 root 5 at an angle of minus 153.43. After solving by calculator, you will get 2.314 at an angle of 131.56. So we can represent I1 plus I2 in cos term like this. 2.314 cos 100t plus 131.56. Okay. Now this value and this value both are same. So let us conclude this. So finally I am getting I1 plus I2 is equal to 2.314 sin 100t minus 138.43 in sine form, or in cosine form I am getting 2.314 cos 100t plus 131.56. Both are same, both are equal, only the difference is one is represented in sine form and one is represented in cosine form. If you want to check whether these two are equal or not, put t is equal to 0, you will get same value. At t is equal to 0, sine minus 138.43 is equal to cos 131.56. So you can check by calci. Now most of the guys don't know how to convert polar into rectangular or rectangular into polar in order to add or multiply the two complex value. Okay, because in GATE exam you will not get scientific calculator, so you have to do it by yourself. So suppose any rectangular form a plus bi, I is the imaginary part, is given, and you have to convert this into polar form having magnitude a at an angle of theta. Okay, so a can be found by under root of a square plus b square, and theta can be found by tan inverse b by a. Got it? Now suppose any polar form is given, theta, a angle theta, and you have to convert into rectangular a plus bi. Now here a can be found by a cos theta and b can be found by a sin theta. So you have to know these things in order to convert polar into rectangular, rectangular into polar. So after adding, I am getting 2.314 sin 100t minus 138.43, that must be equal to 2.314 cos 100t plus 131.56. Why I have added this, I will let you know after this problem. Now take this problem. See, here two sources given having same frequency. Okay, this is having same frequency and this is having same frequency, but the difference is one is given in cosine form and other is given in sine form. Okay, and you can see here that this is nothing but the superposition of these two network, which we have already explained. This network and this network, if I will superimpose these two network, then I will get this network. If I will take 20 cos 100t at a time and I will short circuit this voltage source, then I will get this network. Okay, 20 cos 100t plus 30, and I will short circuit this. Similarly, if I will take 20 sin 100t and I will short circuit this voltage source, then I will get this network. So we can say that if we will apply superposition theorem in this question in order to find the response, then I will get the solution like this only, because in superposition theorem the algebraic sum of individual response will give you the total response. Okay, that's why we have added here, because if I will solve this circuit, then the response must be equal to whatever I am getting here. Got it? So here two voltage source are given and one is given in cos and other is given in sine. So there are two methods of solving these questions. First one is the superposition, second one is the nodal. So by superposition we have already did in previous problem by taking one voltage source at a time, and finally we are finding the response that is equal to I1 plus I2, that is equal to this much. Okay, so I will not go with the superposition, I will go with the nodal method, and I will find the response and I will verify that whether I1 plus I2 must be equal to I or not. Okay, now in order to find the response by using nodal, first you have to convert either cos into sine or sine into cos, then only you can represent this voltage source in phasor domain. In all the book you will see that they are taking cosine as a reference and they are converting sine into cos. However, this is not the necessary. You can take sine as a reference and you can convert cosine into sine form. So I will go by both the approach so that you can understand that it is not necessary that you always take cos as a reference or sine as a reference. It is up to you, whatever you want to take you can take, but the voltage source must be in the same reference. Means if you are getting sine as a reference, then you have to convert cos into sine, or if you are taking cos as a reference, then you have to convert sine into cos. So first I will take cos as a reference and I will solve this circuit. So if I will take cos as a reference, then what I will get, I will take this as a 20 at an angle of 30. Why? Because I am taking cos as a reference, so 20 at an angle of phase shift. Okay, now we have to convert this sine into cos form, so we can write this 20 cos 100t minus 90. Okay, so this will be 20 at an angle of minus 90. So in this problem I have taken cosine as a reference, then the response I will get in cosine form only. Now I have to find the I. So I will apply nodal. V minus 20 angle 30 upon 2 plus V by 2 plus V minus 20 at an angle of minus 90 upon J2 is equal to 0. So V 1 minus 0.5 J is equal to 10 at an angle of 30 plus 10 at an angle of minus 180. So finally I will get V is equal to 4.6298 at an angle of 131.56. Now tell me, what is this? This is the maximum value. Why? Because I have taken in phasor maximum value. 20 is the maximum value and this 20 is the maximum value. So I have taken the source voltage as a maximum value. So the response will must be in maximum value. Now in order to find I is nothing but V by 2. Okay. So V by 2, if you will divide this V by 2, you will get 2.314 at an angle of 131.56. Now represent in cos wave. What you will get? 2.314 cos 100t plus 131.56. This is the value of I flowing in 2 ohm resistor in cosine by taking cos as a reference. Now this must be equal to I1 plus I2 if I will go with the superposition. Now let us match this. Here see, in cosine form, this is 2.314 cos 100t plus 131.56, that is I am getting in this 2.314 cos 100t plus 131.56, because I have taken cos as a reference and I am converting sine into cos form. Now same problem, if I will take sine as a reference and converting cos as a sine form, then what I will get, I want to see. Now what I am doing, I am taking sine as a reference and I am converting cos into sine form. So if I will take sine as a reference, then I will write like this: 20 at an angle of 0, because here is no phase shift by taking sine as a reference. Now you have to convert this cos into sine. We know that sine 90 plus theta is equal to cos theta, right? If I will put theta is equal to 100t plus 30, then sine 90 plus 100t plus 30 is equal to cos 100t plus 30. So finally if I will convert this cos into sine, then I will get 20 sine 100t plus 90 plus 30, that is equal to 120 degree. So I can make into sine like this: 20 at an angle of 30 degree. Here I am taking sine as a reference and I am converting cos into sine. Now see the response what I will get. If I will apply nodal, then V minus 20 at an angle of 120 by 2 plus V by 2 plus V minus 20 at an angle of 0 by J2 is equal to 0. V 1 minus 0.5J is equal to 10 at an angle of 20 plus 10 at an angle of minus 90. So finally I will get V is equal to 4.6298 at an angle of minus 138.43. Now current I is equal to V upon 2, that is equal to 2.314, and what I have taken sine as a reference, so the response must be in sine. So sine 100t minus 138.43, this must be equal to I1 plus I2 that we have derived in the previous problem. So see here, you are getting 2.3414 sine 100t minus 138.43. We are getting same by nodal also. So it is not necessary that you should take cosine as a reference or always convert sine into cosine form. You can take sine as a reference also and convert that cos into sine. However, in book you will see that they are taking cos as a reference and converting sine into cos and then solving by nodal method. Got it? So don't mug up each and everything. You should know the concept. You can take it anything what you want. In the next problem, what I did, I have changed the frequency of supply voltage. Here I have taken 20 cos 100t plus 30, and here I have taken 20 sine 200t plus 30. Means we are applying two different voltage source having different frequency. Here I am having different frequency. So in any kind of AC circuit, if you are getting multiple voltage of different frequency, then you cannot solve that circuit by using nodal. Means we cannot solve this circuit by taking two voltage source at a time. So superposition theorem is the only option left. In this question, we cannot use nodal method by considering two voltage source at a time because the frequency of two voltage source are different. So we can solve this circuit by using superposition theorem only. Only superposition theorem can be applied here. Okay. We don't have any other option in order to find the response of this kind of circuit where two voltage source having different frequency are given. So if you will go with the superposition theorem, then you have to consider one voltage source at a time. So if I will take this one voltage source by short circuiting the other voltage source, then I will get this circuit. This is 20 cos 100t plus 30. This is 2, this is 2, this is J2. And the second circuit I will make, I will find this I1, and second circuit I will make by short circuiting the first source. This is I2 J2 and this is 20 sine 200t. So overall response of the circuit I will get, that is equal to I1 plus I2, and we have already find the I1, the value of I1 and I2 in the previous problem. We found the value of I1, that is given as 2 root 5 cos 100t plus 56.56. Okay, and the value of IT is given as 2 root 5 sine 100t minus 63.43. This we have already find in this problem. So the magnitude will remain same, only there is difference in frequency. In place of 20 sine 100t, I have taken 20 sine 200t. So in place of 100, this will be 200. So finally I will get the value of I1 and I2 is equal to minus 63.43. Okay, so the net current will be I is equal to I1 plus I2, that is given by 2 root 5 cos 100t plus 56.56 plus 2 root 5 sine 200t minus 63.43. We cannot add this I1 and I2 directly like we have added in the previous problem. We cannot add like that because the frequency of both the signal are different. The frequency one having frequency 100 and other having frequency 200. So we cannot add directly. There are method to add this waveform also. This I will take in when I will teach you power calculation in single phase and three phase circuit. That is the lecture number 22. Okay, so wait for that. Up till now we can find the response by using superposition theorem only if the frequency of voltage source are different. There is no any other options available in order to solve the circuit. Okay, now see the next problem. Here also two voltage source are given having different frequency. This is having frequency is equal to 0 and this is having frequency is equal to 2. So we have only one option, that is the superposition theorem. We cannot apply nodal method here in order to find the response because the voltage source having different frequency, right? So if I will solve this problem by using superposition, then I have to take one voltage source at a time. So suppose I am taking 10 voltage source and I am short circuiting this 5 cos 10 2t, this voltage source. Then this is DC circuit, and at a steady state we know that inductor can be replaced by short circuit and capacitor can be replaced by open circuit. So overall this will be open and this will be shorted because we are applying DC. Now we have to find I1t. So I1t is nothing but 10 upon this resistance, that is equal to 2, that is equal to 5 volt, that is constant. Okay, now if I will take 5 cos 2t, then what I will get? I will get the circuit like this. Now we have frequency omega is equal to 2, so find the reactance of inductor. Reactance is equal to omega L, j omega L, that is equal to J2, and the capacitive reactance is equal to 1 upon j omega C, that is equal to 1 upon 2j because the C is 1 farad. Okay, now you can apply nodal method because you have made the circuit having one voltage source and having frequency omega is equal to 2. Okay, now apply nodal here. You will get V upon 2j plus V by 2 plus V minus, if only one excitation is given, so we can represent this like 5 angle 0, where 5 is the maximum value. We have to keep in mind that I am taking 5 as a maximum value. So V minus 5 angle 0 upon 1 upon 2j is equal to 0. After solving this equation, I will get V is equal to 2 root 10 at an angle of 18.43. Okay, so I2t, let us suppose this is I2t, is given by V by 2, that is equal to root 10 at an angle of 18.43. So in wave form I will write under root 10, this is the maximum value because I have taken source voltage as a maximum while converting into phasor form. So root 10 cos 2t minus 18.43. Now the net current will be the algebraic sum of these two currents. So IT is given by I1t plus I2t, that is equal to 5 plus root 10 cos 2t minus 18.43. Okay, this is the answer. So in this way we can solve any kind of AC circuit, and now I am thinking that you will not get any problem whether to take maximum value, whether to take RMS value. You can take whatever what it is, but if nothing is given about the excitation, then always take that value as a RMS value. Now after studying this much, we can conclude that when nothing is given about excitation, then always take that value as an RMS value. Means if the circuit is, you will get like this. If the circuit you will get like this, and there is one voltage source having 2 angle 30, and you don't know about the excitation whether it is sine or cosine, means this value is an RMS value. Always take this value as a RMS value. This is the first conclusion. Okay, now the second conclusion is this: when only sinusoidal excitation is given, then take sine as a reference. Means if only one voltage source having sine wave is given, sinusoidal excitation is given, then take this as a reference. No need to convert into cos. In the book you will see that they are converting into cos and then they are finding the response in cos. No need to do that. Take this sine as a reference, that is 20 angle 0, where this 20 is the maximum value. You can take RMS value also, no problem, but after finding the response you will get the response in RMS value. Then you have to convert again into maximum value in order to represent in sine form, right? So take this as a maximum value for convenient, and then solve this circuit by using nodal. You will get IT, right? So the conclusion number 3 is when only cosinusoidal excitation is given, then take cos as a reference. You can take this cos as a reference. You can replace this as a 20 at an angle of 30 degree because phase shift is 30 degree, and finally you can find this response I1t, that you will get some magnitude. Okay, and since you have taken the cos as a reference, so this will be cos 100t and some angle phi. Okay, no need to convert this cos into sine or sine into cos if only one source is given. Now the conclusion number 4 is when both sine and cosine excitation having same frequency, the frequency is same, here also 100, here also 100, so having same frequency is given, then take any one as a reference and make other on same reference. Means you can take cos as a reference and you can find the response, no problem, or you can take sine as a reference and you can find the response, no problem. Like this, if you are taking cos as a reference, then you have to take 20 at an angle of 30. Since you have taken the cos as a reference, so now you have to convert this sine into cos form. So we can convert this sine 100 cos 100t minus 90. So overall this will be 20 at an angle of 90, and find the response. The response you will get, since you have taken the cos as a reference, so the response you will get in cos form, right? Now if you want to take sine as a reference, no problem, you can take sine as a reference. Then this will be 20 angle 0 and you will convert this into sine, then you will get 20 sine 100t plus 120, means 20 at an angle of 120. Finally the response you will get in sine form. Don't by heart everything that you have to take cos as a reference only. There is nothing like that. You can take whatever it is, but you have to bring others into same reference frame. Got it? Now the final conclusion number 5 is, when both sine and cosine excitation having different frequency is given, then only superposition theorem can be applicable. See here, omega is equal to 100 and here omega is equal to 200. So we cannot make this into phasor form by considering two voltage source at a time, because the frequency of both the sources are different. So in this way only superposition theorem can be applied. So if you will apply superposition theorem, then you have to short circuit this voltage source and you have to consider this, then again you have to short circuit this voltage source and you have to consider this. Finally you will get I is equal to I1 of t plus I2 of t. That will be the answer. And the both I1 of t having frequency 100 and I2 of t having frequency 200, so both cannot be added directly. There is a method to add this type of equation which I will explain later on. Got it? So that's all about AC analysis. In the next lecture we will see the phasor diagram of series, parallel and some problem based on this phasor diagram. If you guys understood the concept, then please like this video and subscribe to the channel. For doubt solving, you can join our Facebook group. Thanks for watching this video.